Assalamu alaikum everyone. My name is Asfandia Mansoor Abbasi and we are here to discuss our final year project, Virtual Telepresence Robot. As we have already completed two of our milestones, one was gesture control robot and the other was base design. I am here to explain base design. The base design was designed on AutoCAD. The aerodynamics were set in such a way that it can bear up to 30 kg of weight. The weight will not in any way incur or dilute any movements. The base has three compartments. The base is basically made up of aluminum and acrylic sheets are used to separate each compartment. We have three different compartments, one for camera, other for power distribution board and one for circuits. Now my friend will continue.
Assalamu alaikum everyone. My name is Talha Khurshid and I am going to describe about the main components and gesture controls in our project, which is the MPU 6050. It has both a 3-axis accelerometer and a 3-axis gyroscope integrated on a single chip. The gyroscope measures rotational velocity over time. The outputs of a gyroscope are in degrees per second, so in order to get an angular position we just need to integrate the angular velocity. On the other hand, the MPU 6050 measures acceleration in the same way as the gyroscope. It can measure gravitational acceleration along the 3-axis, and using some trigonometry math we can calculate the angle at which the sensor is positioned. So if we combine the accelerometer and the gyroscope data, we can get very accurate information about the sensor orientation. The MPU 6050 is called a 6-axis motion tracking device because of its 6 outputs, 3 accelerometer outputs and 3 gyroscope outputs.
Assalamu alaikum. So talking about the NRF modules, these modules are very popular among the Arduino tinkerers. The NRF24L0 is widely used in wireless communication and are actually transceivers which actually transmits and receives data. These are very cheap and can be used in many microcontrollers. So now for handling the wireless communication, these are actually bidirectional communication between the Arduino boards while using the joystick or IMUs at first Arduino. We will control the servo motor at the second Arduino. This module uses 2.4 GHz band and a baud rate from 250 kbps to 2 Mbps, and if used in open space they can give you a range more than 1 kilometers. And the power consumption of this module is around 12 milliamps, and the operating voltage of this module is from 1.9 to 3.6 volt, but the pins can tolerate up to 5 volts logic.
In the end, I, Ashir Iqbal, will tell you about the whole working of a gesture control robot movement. As my groupmates already told you about the components we use, so let's start its working. To transmit our signals wirelessly, we have two ends. One is transmitter and the other is receiver part. Transmitter is located at a gesture glove to transmit signals, and here by signals we mean the gestures we are making. At the robot we have receiver part, which is receiving those signals which we are transmitting. On the whole, we have 5 movements, and for those 5 movements we have 5 different and distinct hand or glove positions. For transmitter part, we use Arduino Uno to power it up, and for receiver part, we use Arduino Mega. Arduino Mega is giving power to receiver part. To run motors, we have used motor driver, that is L298 module, and for our whole power, we have used a power bank. And that's also the working of our gesture control robot movement using MPU 6050. We have also done this gesture control robot with the help of flex sensors. But one flex sensor was costing us 3500 rupees, and for 5 movements, 5 flex sensors were required around 17,500 rupees, which is a big amount. So we used MPU 6050 instead of flex sensors, which cost us only about 350 rupees. And now while concluding this, I would like to tell you about our next milestone, which is distant communication. And thank you. On gesture glove, we have used Arduino Uno, NRF sensor with antenna, and MPU 6050. This NRF sensor is used as transmitter on gesture glove. On robot part, we have used Arduino Mega, a motor driver to run motors, and another sensor with antenna to increase its range as it is a receiver. Now any signal which is being transmitted from our gesture glove is received by our robot, and our robot will move according to our gesture. Now we are at stop position and our panel will show us S. Now we are in forward position and our panel will show us F. Now we are at left position and our panel will show us left. Now we are in the right position and our panel will show us R on the screen. And now in the end our final position is backward, and now our panel will show us B on the screen.